Hello everyone, I'm Ife, and today we're going to talk about my project, which revolves around the issue of diabetes. Diabetes is a global public health concern that is almost faced by every family in the world. According to the Centers for Disease Control and Prevention, 34.2 million adults have diabetes in the US alone, and 1 in 5 of them don't know that they have it. The International Diabetes Federation has also stated that there were approximately 415 million adults between the ages of 20 to 79 who had diabetes mellitus in 2015, and this number is expected to rise by another 200 million by 2040. Type 2 diabetes mellitus, or T2DM, accounts for 90% of all diabetes. In other words, almost 1 in every 10 adults in the world have T2DM. Hundreds of millions of people around the globe suffer from T2DM every day. T2DM is when the response to insulin within the body is diminished, also defined as insulin resistant. Although this is most commonly seen in people older than the age of 45, the number has been increasing in small children and adolescents in the past few years. Ginger is one of the most commonly consumed dietary condiments in the world. Therefore, ginger is relatively safe, as long as it is not taken in too excessively. Over the years, ginger has shown to help improve blood sugar levels and help regulate the insulin response in diabetics through multiple researches. However, that's not enough. Scientists hope that there can be more benefits that ginger can offer to humanity. Diabetes has long been considered as a disease that shortens life expectancy. As research done on diabetic mice model has shown a tendency to a shorter lifespan than the average Drosophila. Another research concerning diabetic mice model has shown that obese mice model fed with a polyherbal preparation containing 5% ginger acarus extract has resulted in a significant loss of weight and an increase in its locomotion ability afterward. Our project is to find out if ginger can become a novel treatment for T2DM patients by testing various concentrations of ginger powder on both wild-type Drosophila and T2DM Drosophila models, then looking to see if any of them had a higher life expectancy compared to previously. It is predicted that the treatment of 1.5 mg per liter of powdered ginger will be the most effective treatment.
In the first experiment, we tested the locomotive ability of wild-type Drosophila groups compared to the type 2 diabetes model Drosophila groups, both of which offer varying concentration of ginger powder depending on their respective groups, with a sample size of 10 for each group. In order to test for Drosophila's locomotion, we use the lacamic acid. In the lacamic acid, we have to transfer all the Drosophila to a new food well. The day before the lacamic acid was performed, this was done to help reduce wet food from inhibiting the Drosophila's climbing ability. First, we place a group of 10 flies in an empty climbing well and tap down all the Drosophila to the bottom of the well and drew a data line that is 5 cm from the bottom of the well. Then a timer is set for 18 seconds to let Drosophila climb past the data line, which is marked 5 cm from the bottom of the well. We record the Drosophila that passed 5 cm line during the 18-second period. After a timer was set up, After the timer was up, we had collect our data. We performed this process again for each single group of Drosophila we had, which means this process is performed in addition 4 times. 5 separate trials should be run afterward, so there will be a total of 25 tests. Data will be analyzed and recorded in percentage, and the Drosophila will be tested on day 5, 10, 15, 20, 25, and 30 post-occlusion. After we had analyzed the data, the graph of effect of ginger powder on wild-type Drosophila and diabetes model Drosophila's average climbing ability was shown in the result part. Arrow bar represents plus and minus 1 standard deviation of the mean. Stats sign note a significant difference between the groups for varying concentration of powder ginger. The moderate ginger powder did not significantly help their locomotion compared with the control group in wild-type Drosophila. However, we can clearly see that concentration of 1.5 mg per liter ginger powder had the greatest increase compared to the control group in the locomotive function of diabetes model Drosophila, and it is significant, making the diabetes model Drosophila capable of locomotive ability close to the wild-type Drosophila.
In the second experiment, we tested the lifespan of the wild-type Drosophila group compared to the D2DM Drosophila group, both of which were also fed with varying concentration of ginger powder, depending on the respective group with a sample size of 50 per group. We use a rather simple process in order to measure the Drosophila lifespan. First of all, we breed a lot of Drosophila, because we will need numerous Drosophila for the lifespan assay. After recording the day each Drosophila was born, we place the Drosophila into vials with similar environment, and separate them into each vial by their birth date, and hence classifying them into different groups. Finally, we fed the Drosophila food with varying concentration of ginger powder for 50 days. Within the control group, we had a total of 5 separate groups of wild-type Drosophila, and within the experimental group, we also had 5 different groups of Drosophila. However, the Drosophila in the experimental group were T2DM Drosophila. We fed all the control groups with Drosophila food, each mixed with different concentration of powdered ginger, which is respectively 0, 0.5, 1, 1.5, and 2 mg per liter. We also did the same for all the experimental groups. We recorded the number of dead Drosophila in each group every 10 days for 50 days. As a result, Drosophila food mixed with a treatment of 1.5 mg per liter of ginger powder was the most effective treatment, which proved our hypothesis to be correct for both experiments. The reason why we have reached to such a conclusion is probably the same reason as we have stated in experiment number 1. All error bars in figure 6 are plus or minus 2 SE. The error bars were quite small, meaning that there were little variation within the data. A significant difference, which meant that there is a 95% or more chance that one will observe this difference again, was denoted by a hashtag for data between the experimental and control groups, while a star for data between the experimental groups. For future research, the experiment could be repeated in human volunteer experiments using different concentration of ginger powder and testing different dependent variables. For this project, we used only Drosophila as test subjects, so we don't know what would happen if we did the same thing for humans. Also, a larger sample size, like maybe n equals 100, will help to make the data and experiment more accurate too.
In conclusion, after intense observation and analysis of our 2 experiments, it was found that 1.5 mg per liter ginger powder was the most effective treatment for both wild-type Drosophila and type 2 diabetes model Drosophila. The concentration of 1.5 mg per liter ginger powder is the most moderate concentration of ginger powder too, because too low of a concentration will have little or no effect, while too high might cause side effects. We also find out that overall, the groups that were treated with powdered ginger groups were found to have life expectancies than the groups that weren't treated with powdered ginger. This is why we think that ginger powder can definitely be used as a drug to treat with diabetes patients with locomotive syndrome and perhaps extend their lifespan than what it could have been originally. Ginger has also previously been found to be good for diabetes in many other ways, such as helping to control high blood sugar levels and aiding the regulation of one's oxidative stress. This is why ginger powder could be very reliable treatment for diabetes. However, further research could be need to done in order to find out the suitable ginger powder concentration used for human and whether if ginger can be actually solve and cure diabetes.